Hello everyone, welcome back. I am Chetan Rajoria from the Department of Mechanical Engineering, ABES Engineering College, and I welcome you all to this another video session of lectures. In this video lecture, we are going to discuss another numerical problem based on free body diagrams and the equilibrium of forces. So let us see the problem. So students, this is the problem which we are going to discuss here. Two smooth rollers, P and Q, having radius of 25 centimeter each and weights 500 newtons each, rest in a vertical channel having vertical walls. The gap between the walls is 90 centimeter. Calculate the value of reactions at points A, B, and C. Look at this diagram. This is the vertical channel which we are talking about here. These are the two rollers, or you can say spheres, which are being considered as smooth, frictionless. This is the point of contact between these two rollers. The size means radius of these two rollers are same. The gap between these two vertical walls, the right side and the left hand side walls, is given 90 centimeter. So let's mark this distance here. This distance is 90 centimeter. Okay. We need to calculate the reactions at point A, B, and C. This is the point A. This is the point B. And this is the point C. We need to calculate the reactions at these 3 points. So let's proceed. First of all, we will decide which roller is to be considered first. As we can see quite clearly that the first roller is having 2 unknown forces right now. The force at point of contact between these two rollers means at this point and at this point, and the reaction from point B. If we consider the lower side roller, we can see that there are 3 unknown reactions at point A, C, and this point of contact. Suppose this point of contact is D. Okay, so there are 3 unknown reactions. So we will consider the upper roller first. Before proceeding ahead for drawing the free body diagram of this roller, we need to calculate the inclination of the common reaction between these two rollers, okay, which is passing through point D and is acting between the centers of these two rollers. We need to calculate this inclination, this angle theta. After that, we will draw the free body diagrams. So how to calculate the inclination of this mutual reaction between these two rollers? For this, we will use the geometry of the figure. Please observe carefully that the gap between these two vertical walls is 90 centimeter given. If we drop this vertical vector to this level or up to this level, this gap is clearly equal to the radius of this roller. The radius of this roller is 25. So this is 25. Okay. Similarly, the gap between the center of this lower roller and the point A is once again 25 centimeters. So this side is 25, this side is 25. Therefore, what is the distance between this point and this point? Means the horizontal distance between the centers of the roller. This will be 90 minus 25 minus 25. 90 minus 25 minus 25. This will be the gap, the horizontal gap between this point and this point. You can see the horizontal gap between the centers of the roller. Now, what is the distance between the centers of the roller? Can you see this? The distance between the centers of the roller is the summation of their radius. The radius is 25, so the distance between these two centers will be 25 plus 25, that is 50. So we are obtaining a triangle, a right angled triangle here. And in this right angled triangle, the base is 90 minus 25 minus 25. And the perpendicular, sorry, the hypotenuse is 50. Using these two dimensions, we can calculate this internal angle alpha. So according to the basic trigonometry, alpha will be, or you can say previously we shown this angle as theta. So let's mark it as theta. So theta will be equal to cos inverse base upon hypotenuse. 90 minus 25 minus 25 upon 50. So this is clearly 40 upon 50. Cos inverse 40 upon 50. We can calculate this value and it is coming to be 36.87. Okay. Now we got the inclination of this mutual reactions between these two rollers. Now you can proceed ahead for drawing the free body diagrams. First of all, we are going to consider the upper roller, free body diagram of the first roller. So this is the free body diagram of the upper roller. The weight of 500 newtons. The reaction from this vertical wall will be horizontal and it will act to the left hand side. Suppose this reaction is RB. The common reaction, or you can say the reaction from the lower roller onto the upper roller will act in the upward direction, inclined upward. So we can show it like this. This is the reaction from the lower roller on the upper roller. So we can show it as R, simply R, the common reaction between these two rollers, and the angle is theta, which is already known. We already calculated this angle theta. Now we can use Lami's theorem or simply the resultant, or you can say the equilibrium equations for the calculation of R and RB. So let's write the equations. Sigma fx equals to 0. So we can write RB, sorry, minus RB plus R cos theta 36.87 equals to 0. This is the first equation because RB is acting to the left. We consider left hand side direction as negative. And R cos 36.87, the horizontal component of this reaction is acting towards right hand side. Therefore, it should be positive. So this is the first equation. Summation of forces along x-axis. Now let's write summation of forces along y-axis equals to 0. So what should be the equation? R sine theta, which is acting to the upward direction. R sine 36.87, R sine theta minus 500. Because this weight is acting downwards. So it should be considered as negative, is equal to 0. Suppose this is the first equation and this one is the second equation. Using the second equation, directly we can calculate the value of R. So R from second equation, R is equal to, clearly it's 500 upon sine 36.87. So by calculation, we can get R is equal to 833.33 newtons. This is the mutual reaction between these two rollers, which is inclined at the angle theta, 36 approx. So this is the value of R. Let's put the value of R in the previous, any one of these two equations. We get RB equals to 666.66 meters. How we get this value? By putting the value of R in any of these two equations, either 1 or 2. We cannot put the value of R here because there is no value which is representing RB. So we need to put the value of R in the first equation only. So by using the first equation, we can get the value of RB. And the value of RB is coming to be 666.66 newtons. So that is you can say the first answer. Now, let's consider the free body diagram of the lower roller. Okay, free body diagram of the lower roller. So let's draw it. This is the weight of the lower roller, which is 500 Newton once again. The reaction from point A will act towards the right, like this. Okay, from point A, the reaction starts like this. And I'm going to show this reaction at the center of this roller according to the principle of transmissibility. Okay, so this is RA. Now we will consider the reaction, or you can see the force from the upper roller on the second roller, or you can see the lower roller. So the force will be R, but the direction will be opposite. In the previous free body diagram, the direction was inclined upward because we were considering the force on the upper roller from the second roller, you can see the lower roller. But now what we are considering? We are considering the force on the lower roller from first roller. So the direction will be reverted, but the inclination will be same theta. So sorry, this is the reaction from the upper roller onto the lower roller, R. And the value of R is 833.33 newtons, already calculated this place. So the inclination is, what was the inclination? Theta. Inclination is 36.87 degrees. 36.87 degrees. Now there is one more force, RC. From point C, the reaction will act like this. So I'm going to show this reaction at the center of the roller as usual. So this is the reaction RC. So this is the complete free body diagram of the lower roller, roller P. Let's write the equilibrium equations for the lower roller. Sigma Fx is equal to 0. Summation of forces along x-axis should be equal to 0. So 833 cos 36.87 negative 833.33 cos 36.87, and it should be negative because it is acting to the left hand side. Okay, minus RA. Sorry, it should be positive, plus RA is equal to 0. From this, we can calculate the value of RA directly. We can see that RA is equal to 666.67 newtons. Okay, so this is our second answer. Now let's write the equilibrium equation for the vertical forces. Sigma Fy equals to 0. So what should be the equation? RC, which is acting vertically upward, it should be positive. So RC minus 833.33 sine 36.87. Sine 36.87 degrees. This is the vertical component of this force, and clearly the vertical component is acting to the downside. Therefore, it should be negative. Minus 500. This is clearly to the downside. Should be negative as per our usual sign conventions. So RC minus 833.33 sine 36.87 minus 500 should be equals to 0 because there will be no vertical component of RA. So from this, we can calculate the value of RC. And by calculation, this value is coming to be RC is equal to 1000. We can calculate using any calculator. RC is equal to 1000 newtons. So this is our third answer. So in this way, using the concept of free body diagrams and the concept of concurrent force system, we have calculated these three unknown reactions at point A, B, and at point C. We have also used some basic geometry of the figure, and we calculated the inclination of this common reaction between these two rollers by using the geometry of the figure. So that's all for this session. Thank you so much.